I am Bhakti Patankar Rajvedya from Applied Physics Department of GH Raisoni College of Engineering, Nagpur. Welcome to the video lecture series of Physics. The first topic today I am taking is Introduction to Physics. I will be covering in the lecture who is physics, why physics, how physics, what is physics and where exactly is the application of physics. So, to talk about who is physics, let us talk about the history of physics. In ancient era, when everyone was fascinated by the different processes going on the earth, off the earth, in the sky or beneath the earth, everyone was having their own definitions to define the things that are occurring around them. At that time, the earth was supposed to be considered as the center of the universe and every planet is taken around it. But when the Copernicus around 90 AD was the first thinker who thought and proposed the theory, and he said that earth is not at the center of the universe, but the sun is at the center of the universe, and he proposed first time the planetary system, planetary model of the universe. He was completely denied by the group of people at that time, but later on when Galileo in around some 90 AD proved the theory of Copernicus to be true, we can say the actual beginning of physics occurred. Then around 200 BC, when Archimedes was a scientist who has given the principle of Bion's force, when some object of its weight can displace some amount of water and make the floating over the water surface, we can say an breakthrough in the field of physics occurred another. Today also we are having the water transport, the ships and the cruises floating on the water and getting transported from here to there, was the first basis was given by Archimedes. Then in 1700 Sir Isaac Newton came forward and he almost proposed each and every field his own theories and propositions. His famous theories were the laws of motion, the gravitation, and also he has said something about light which was not accepted at all. But still Newton was considered one of the forefathers of physics. Then in 1800 some more scientists came forward. The mechanics which Newton proposed was considered as a classical mechanics or Newtonian mechanics, but the laws of the mechanics were restricted to the celestial objects or big size objects. But when during 1800 centuries, when the discoveries of smaller and smaller dimension objects were made, like atoms and the subatomic particles like electron, when Sir J.J. Thomson studied and discovered the existence of electron inside the atom, then they found that the laws of Newton, the Newtonian mechanics or classical mechanics, is not applicable to the objects of that small dimension. And then the new era of physics began, we can say the quantum physics. The forefathers of the quantum physics was Max Planck, Heisenberg or Albert Einstein. Max Planck, who was the first one to propose that the energies are always in the form of packets or bundles of energy, where each packet he called it as quanta. Einstein applied that concept to light and proposed the name photon to the light packet, light bundle, and he proposed his famous photoelectric effect, for which he was awarded with the Nobel Prize, not for his famous theory of relativity, which still now is a mystery and yet to be opening up. Then next physics come what we are going through today, we call it as modern physics. Now modern physics deals with all these classical quantum physics together, where they are explaining the ongoing phenomena and various technology based, we can say various gadgets are also based on that things. So that is what is physics. To go through a proper definition of physics, we can say physics was a Greek word derived physika, which means knowledge of nature. And in the bookish or the scientific definition of physics is a branch of science that deals with the study of matter, energy and interaction of energy with matter. But this is not only the concise definition of physics, this is not the restriction of physics. You cannot define physics because physics defines everything. Now next thing is why physics. Physics is something which you come across to your daily happenings, your daily occurrences, your day-to-day activities are physics. You are getting woken up by the annoying sound of alarm clock in the morning. That sound waves are striking your ears and making you wake up forcefully. That sound is well studied in a branch of physics that called acoustic, that let us know that sound waves travel in longitudinal manner. They have some 340 meter per second velocity and all. Then when you boil your coffee or tea on the gas burner, that boiling point where the steam is coming out, that is another branch of physics which is studied the heat and its transmission as thermodynamics. Then you drive your car towards your office or your college, and that driving is nothing but a motion. That motion is studied in specific things of motions, maybe circular, translational, all kinds of motions. Then in office you watch your laptop, your mobile phones, the screens are made up of the technology that is LED technology, that is another branch of physics which comes or derived from the basic semiconductor physics. So even if you are coming back home and for getting relaxed, you are swimming in your pool, that you are floating on the water, at that time you must remind Mr. Archimedes, thanks to him that we can float on the water and get swimmed. So this is everything you are discussing, not only the things you are doing, but also you are yourself a physics. You are made up of small body parts called cell. That cell consists of DNA, and that DNA is made up of protein. Each protein has atoms. That atom is nothing but physics, which is studied in its separate branch called atomic physics. Even your body needs to be treated when you are not well, when you are suffering from certain disease. You are treated, you are diagnosed with different techniques like MRI, NMR, or the tissues are observed under the microscope. That is a separate thing, separate branch of physics called biophysics. So that's why we should learn, we should have a sufficient knowledge of this huge or vast subject physics. So that's why we should go through physics. Now how we can learn physics? So it depends upon the area where you are interested in. So this how question satisfies this globe. If you are interested in formation of universe, how the universe was formed, the Big Bang theory, which is currently being studied in the Large Hadron Collider. So that is nothing but cosmology. The cosmology helps you to study universe, the expansion of universe, the contraction of universe, the formation, evolution of universe and all. If you are little bit interested in the parts of universe like astrophysics, what is the universe made up of, the compositions of universe, the planets, the stars, the asteroids or satellites which we are sending, man-made creation inside universe, that can be studied in the term called astrophysics. If you are more down to earth person, then if you learn about, if you want to learn about earth and its geographic condition, then there is a separate branch called geophysics, where you can study the earth crust and various waves or maybe volcanoes, eruptions, all the things you can study, or the constituents of earth crust, the minerals, the rocks, etc. can be studied using geophysics. Then you have the applied basic or engineering physics, what we call in the normal term, that is the physics which deals with the study of force, motion, pressure, maybe kinetic energy, potential energy, maybe all different terminologies we are learning from the childhood till now date, that comes in the modern physics or physics category. Then going down the scale little bit, you can go at the cell dimension of your human body, and study of all that comes in biophysics. If you want to break down the cell, if you want to go in the atomic level, you can have atomic and molecular physics, where you can see the crystal structure, the clusters, the tissues, everything. If you want to go or break more inside the atom, then you can go inside the nucleus, and where you can have the nuclear forces, the nuclear fission, nuclear fusion kind of reactions, which are used for energy generations. Nowadays we have nuclear power reactors and all, so that comes in nuclear physics. If you want to go more down the scale, then the nucleons, which are getting bounded together by some elementary particle forces, so that is elementary particle physics, we can say. Also, there is a separate branch of physics called photonics, which is basically dealing with the study of light, not as a wave but as a particle, photons, and they are now having the transmission of photons for the communication or the purpose as electron is doing. So, it is a separate branch of physics. So, this is how you can study physics, whatever you are interested in. Then next is what exactly is physics? Physics is something which is letting you to see me, because the light waves are reflected from here and getting captured inside the camera. So, that all thing recording is physics. Physics is something you are hearing my sound, the sound waves are traveling through this air medium. If I would have been trapped in a vacuum chamber, you may not be able to hear my sound, because the sound cannot travel through vacuum. So, that is what physics deals with. Also, physics is something that will tell you about inertia, why you should have your seat belts on when you drive a car, because if you have a collision, then because of inertia of your body not to resist the change, your body may get a jerk and hit the bonnet. But if you have seat belts on, then this inertia will be stopped. So, this is everything what you come across is physics. Physics will tell you about the temperatures, physics will tell you about the pressure. Physics can also tell you about a minute of the minute or the huge of the huge things. So, that is why physics has its different branches, like statistical physics, which tells you about how many atoms can be in a particular energy level. There can be a thermodynamical physics, which can let you know about the latent heats of very different materials, or melting points or boiling points of different materials. There is a branch of physics called semiconductor physics, which is the basic of all the other branches like electronics, ETC, computer science, IT, because each and every electronic component made up of that small semiconducting devices, maybe a diode, maybe a chip, silicon or germanium chip, maybe a transistor, maybe amplifiers, whatever. So, understanding those things, there are very different branches of physics. Now, where to apply this physics? The last question, how to apply? If I know everything about physics, then what is the use? Why should I know? Why should an engineer study physics? Why should a science person or a technology oriented person should understand the basic things of physics? It is now applicable, we can say, the gadgets, different gadgets, the different technologies nowadays which we are applying are basically on the very different laws of physics. For example, simply if you are seeing some cell in a microscope, the microscopes are having A to Z of different categories. You can go from optical microscope to atomic force microscope to a electron microscope, or maybe confocal microscope. You may have a fluorescence microscope. There are many different types of microscopes only to view a simple cell, and each will give you a different aspect of that cell. Some will give you a 3D image, some will give you a colorful image, some will give you a 2D with perfect dimensions. So, it is as per the requirement. So, if you know the basic construction of that microscope, then you can proceed further into having evolved with more better and better microscopy. So, that is why physics in its optics or maybe microscopy, a person can have more adjustment or more particulation with that microscopy to get it evolved more better. Suppose I am doing with nanoscale things, like I am preparing some nano samples, nano materials, then that is also an application of physics, preparation of nano materials or nanoparticles. How to prepare them? There are various methods. The top down approach or bottom up approach you can apply to create a nanoparticle, or even you can apply that nanotechnology to very different fields. the current researches in the nano going on is nano waterproofing, that you can have nano coatings made onto the substances that will act as a waterproof for that substances. Or we can also have nanofibers which will resist all the muds, dust, etc., and make it easily cleanable. Or you can also have nano drug deliveries, nano robots to operate a human body without intervention of any direct person. So, nano drug delivery or the lotions directly rub onto your skin, where you do not have to inhale or intake the drug orally, you can just have the affected area rubbed with the lotion, and the lotion penetrates through the cells and reach the targeted portion. So, that is all is physics, we can say, where you can apply your knowledge. Then also nano transistor in electronics, if you go down the scale, we all know that electronics has evolved from so many of the years that the computer has reached the size of maybe your mobile phone. Your mobile phone itself is a kind of computer. The size has reduced from a room bulky size to a small palm size. You can even go down that one. Nowadays the electronics is moving towards having a thin structure, where you can even have a chip of size of a paper or even less than that, by the thing what we called it as nano transistors or nano electronics, where a single charge can make out the flow of current through the devices. So, there are lot of different branches, different aspects where you can apply, like superconductors or supercapacitors. If you want to increase the conductivity of a material, then that thing is studied under the heading of superconductors. By going down the temperature, if the conductivity is increasing, then you can reach up that temperatures at even the room temperature atmosphere, you can reach up that state. So, that is nothing but the researches or the research oriented or the open fields for the new or budding, we can say, scientists or engineers to work in. But all this basic is nothing but a physics. Even a chemistry, where chemistries are just dealing with the chemical reactions and interactions of atoms, but that interactions are nothing but in the form of forces, and that forces are nothing but physics. So, each and every branch finds its basic oriented from physics, whether it is chemistry or electronics or maybe any engineering oriented or technology oriented or any pure branch, that is physics. And physics itself goes hand in hand with mathematics, because it has some law to be proved mathematically, practically, and then it can be applied or it can be taken as basics. So, there are some prerequisites or co-requisites for physics like mathematics, chemistry, and these all form the basics for any evolving technology, for working of any gadget, for working of any different instrument or whatever you are thinking of. So, that is why introduction to physics, it was a very difficult topic to be covered, but still by having some 5 questions answered, we have tried to touch up each and every area of this word physica, which was now converted into the proper noun called physics, which deals with the study of everything you come across, everything you see, you may not see, everything you know, you may not know, everything you can feel or you may not feel, everything you imagine or even sometimes you can't imagine, that everything can be explained, maybe already have explained, maybe will be explained, or currently the research is going on, and that is what we can say is the subject physics. Thank you.